Hello, calculus class. We're going to open up to 3.5 in our notes, and we're going to start by identifying the derivatives of all the trigonometric functions. Just to start off, you might wonder, what is the derivative of sine? If I were to just sketch a quick graph, figure this out very quickly. Let's try that again. Remember what the graph of sine looks like. Its greatest value is 1, its smallest value is -1. What we want to do is draw that derivative. It may not look like it from my drawing, but if you were to look at the derivative at 0, you in fact have a value of 1. If you look at the derivative at pi over 2, you have a value of 0. If you look at the derivative at pi, you have a value of -1. If you look at the derivative of 3 pi over 2, or at 3 pi over 2, you'd have a value of 0. You can see that you get this graph. So the red graph is the derivative. You can see that the blue graph is y equals sine of x. You can see that the red graph is y equals cosine of x. So there's just a graphical argument that the derivative of sine is cosine. We can show you the proof. It's rather long and involved. It's really neat, and I would like to show you guys on Monday. But for right now, let's just write them down. So the derivative of sine is in fact cosine. The derivative of cosine is not sine, but rather negative sine. The derivative of tangent is secant squared. The derivative of cosecant is negative cosecant of x times cotangent of x. The derivative of secant is secant of x tangent of x. And the derivative of cotangent is negative cosecant squared of x. You must memorize all of these. Just as you have memorized the product rule and the quotient rule, you'll be expected to do these for your test. So, let's do some simple derivatives. Take the derivative of the following. What is the derivative of -4x? -4. What's the derivative of tangent? Secant squared of x. That is the derivative. That's simple. For b, f prime of x, what is the derivative of 3 sine of x? 3 cosine of x. What is the derivative of 4 cosine of x? -4 sine of x. Yes, it is that simple. C becomes a little bit more difficult. F prime of x, we take the derivative of 3x, which is 3. Then we have this portion right here. X times cotangent of x. All right, x times cotangent of x. That requires the use of the product rule. If you remember, f times g prime is equal to f prime g plus g prime f. So therefore, our product rule, f prime is 1 times g, cotangent of x, plus g prime, the derivative of cotangent, is negative cosecant squared of x times f, or x. So we can write this, f prime of x is equal to, I'm going to put the squared piece first, a negative x cosecant squared of x plus cotangent of x plus 3. That's my derivative. For D, you may look at it and say, let's use the quotient rule. No, let's rewrite it. Because instead of writing 2 cosine of x, I can write, instead of writing 2 divided by the cosine of x, I can write 2 times secant of x. If you're wondering how I did that, you should remember that secant of x is equal to 1 over cosine of x. So once I have that relationship established, I can rewrite the function as 2 secant of x plus 3. Now finding the derivative is simple. The derivative of secant is secant times tangent. 2 secant of x times tangent of x. E. A lot of people would like to take the derivative of the top divided by the derivative of the bottom. It does not work like that. I must use the quotient rule. Remember that the quotient rule, f divided by g prime is equal to f prime g minus g prime f, all divided by g squared. So that is what we will use in this scenario. The derivative of the top, cosine of x, times the bottom left alone. Minus the derivative of the bottom. Derivative of the bottom is 1 minus sine of x times the top. All divided by the bottom squared. Let's see what comes out. Cosine of x times x is x cosine of x. Cosine of x times cosine of x is cosine of x squared. Then I have to multiply this out. If you notice, 1 minus sine of x and 1 plus sine of x, they are conjugates. So as you multiply them, you will get 1 minus sine squared. All over x plus cosine of x squared. F prime of x, we still have that x cosine of x. But do you remember your trigonometric ratios and functions and the relationships? What is 1 minus sine squared? Remember that sine squared of x plus cosine squared of x is equal to 1. Therefore, cosine squared of x is equal to 1 minus sine squared of x. So, if what I just circled in green is actually cosine squared, then the cosine squareds will in fact cancel as you subtract them. So I'm left with x cosine of x over x plus cosine of x quantity squared. And that's it. So a little bit of reducing with our trig. Should be able to do simple reductions such as that. Again, we just pulled from sine squared plus cosine squared is 1. Okay, and f. Our last example. You can see that this does require the product rule. The product rule, we wrote up above, we'll just do again. F prime of x is the derivative of secant. If secant of theta, tangent of theta, times the second function left alone, theta plus tangent of theta, plus the derivative of the second function. Well, the derivative of theta is 1. The derivative of tangent is secant squared of theta, and we will multiply that by secant of theta. The product rule is set up. I'll combine a few pieces here. Secant tan times theta gives me theta, secant theta, tangent of theta. Secant theta, tangent of theta times tangent gives me secant theta, tangent squared of theta. And then if I distribute my secant through on the next side, I have plus secant theta plus secant cubed theta. You might look for something to simplify. For example, a 1 plus tangent squared in some way, shape, or fashion. But in fact, we don't really get anything to simplify here. This is the derivative. And you may say it looks ugly. Well, I suppose it does, but imagine finding that derivative using the formal definition of the derivative. In fact, that would be extremely difficult. This really wasn't that bad. Couple steps, distribute through. Last example, then you can start your assignment. Write an equation for a line tangent to f of x equals 1 minus sine of x at x equals pi over 6. Okay. Write an equation for a line. As soon as you hear that phrase, you should write down two things. M equals and point on the line. Point on the line, my x value is pi over 6. How do I come up with the y value? I plug it in. F of pi over 6 is equal to 1 minus sine of pi over 6. On your calculator, when you plug this in, obviously you have to be working in radians. Hopefully you don't have to plug it in your calculator. You remember that f of pi over 6 is equal to 1 minus sine of pi over 6 is 1/2. So we get 1/2. Slope. How do we determine the slope? Well, the slope is equal to f prime of x. So I need to find the derivative. F prime of x is equal to, the derivative of 1 is 0, and the derivative of negative sine is going to be negative cosine of x. So the slope will be negative cosine evaluated at pi over 6. The cosine of pi over 6 is the square root of 3 over 2, so negative root of 3 over 2. This is my slope. That's my point on my line. Y equals mx plus b. Y is 1/2. Slope is negative root of 3 divided by 2. X is pi over 6. Because I don't like the decimals, I'm simply going to use my just the crazy numbers as they work out. I'm not going to convert everything to decimals here. So it looks like I have 1/2 is equal to negative pi roots of 3 over 12 plus b. As I solve for b, what I need to do is find common denominators, or 6 over 12 is equal to negative pi roots of 3 over 12. So 6 plus pi roots of 3 over 12 is equal to b. Oh, got that b over there, sorry. That's my b value. So for y equals mx plus b, y is equal to m is, we decided was negative root of 3 divided by 2 times x plus b is 6 plus pi roots of 3 over 12. I can't help but always look at the graph in these situations because they're so interesting. I'm going to check my answer by graphing it of 1 minus the sine of x. I'm going to make sure I'm working in radians. I am. My window. Just going to zoom to a standard window. I don't need to see that much of the graph. So I'm going to, my y value, I'm going to bring that down to negative 1. My y max will go to positive 3. I guess I like that better for a graph. And since this looks so crazy, we just got to type it in. And plus, I might be wrong. Who knows? So we have negative root of 3 divided by 2 times x plus, I'm going to need to put some of this in parentheses here, 6 plus pi roots of 3 in my parentheses, divide that by 12. Oh, that's nice. Look at that. It's a nice tangent line. Draw it again for you. Put it in bold. Very nice tangent line. So, confirm that my answer is correct by graphing it. That will take care of our issues. We'll pick up the rest on Monday. And your assignment, again, is 3.5, page 174. Let's do numbers 1 through 16, but not 8 or 10. We'll leave it at that. Have a great weekend.